Hi everyone. Today's video is on the next day of Piecewise. That is target 4. Let me fix that. So you're first going to start off with that concept check quiz. So hopefully you have already done that. And then we're just going to continue our conversation about piecewise functions. When you're done, there is a closer that was in the same spot as this video, as well as then you will finish the homework, which is on the worksheet that it's attached to the handout. Okay, so warm up here. We're just going to practice graphing functions that have domain restrictions to kind of remind you how this works. So a domain restriction, remember, is just when the function doesn't have like infinity to negative infinity as its window. So we're just going to graph this parabola from -4 to 1. Well, it's a parabola that's been shifted down 4. So it's going to do something like this. Okay, so if I were to normally graph it, it would look like this. It would go on forever, but I want it to stop at -1, so I'm going to get rid of anything that comes after -1, so all of this can go away. And then anything that is after +4 also goes away, so I actually should extend this just a little bit more, kind of to there, okay? 4 squared, so if I did 4 squared minus 4, this value up here would be 412. So if you're thinking, like, it doesn't look right, Miss Casey, that's because my graph doesn't quite fit there. And then there should be an open circle here because this -1 is less than and not less than or equal to. All right, so there's the first one. And the second one is an absolute value that's been shifted over 1 and up 3. So over 1, up 3 would have a vertex here. And this one I can probably do just by substituting these values in to help me graph it because we know it's going to be a V. So if I put -2 in for x, I get -2 minus 1 plus 3, which becomes +3 plus 3, which is 6. So -2 is up at 6, closed circle because of the equal to part, so I'm going to connect that line. And then if I do f of 3, well, this will be the absolute value of 3 minus 1 plus 3. So 2 plus 3 is 5. So over at 3, we're going to be up at 5. But it's a closed circle because of the just less than sign. Trying to get that to work well. My stylus isn't working very well. And this should be completely connected. Okay, as I finish or go through the rest of the video here, please make sure to pause and copy things down. So you're going to need to copy the questions down because this was initially intended to be board work. And so you won't have a handout for this. Okay, so copy the problems down as you go. And again, pause if necessary to help you get all the information. Okay, so the first example here is you're going to graph this piecewise function and also figure out the domain and the range. Okay, so the graph is in 3 parts. You've got an absolute value of x plus 2, so an absolute value shifted up 2. You have a line in the middle with a slope of 4, and then you have a parabola. So as you are looking at this and writing this down, you want to think about, I'm going to be graphing a V, a line, and a U shape, okay? But it might not quite look like a V or a U. It kind of depends on the domain restriction we get. And I also see some open circle possibilities going on as well. So I can see open circle here at the -3, open circle at the 1, and then open circle at the 4 for that attachment. I can also quickly come up with the domain restrictions just looking at the information here. So I'm actually going to do that part first. Okay, I don't know that we can get the range quite as easily without graphing it, but the domain we can see starts at -3. That's the lowest value. It goes to 1. 1's not included here, but 1 is included there. So it goes past 1, goes to 4, and then 4 is included here. So it goes all the way past 4, and it actually goes all the way on to infinity. So there's our domain. And like I said, we'll figure out the range once we graph it. Okay. So I'm going to change screens because I already have the graph drawn for you, and then I'll talk about the graph. So let's pull this over. Come on. All right, doesn't want to go that way. We'll just uncover the whole thing. Okay, so here's the graph. And again, it's kind of hard to see what's going on. So I'm going to highlight each piece. So we first have this absolute value graph that was shifted up 2. So that's the little vertex of the absolute value right there. And then this value here, this is over at -3. So that's at -3, comma 3, I think. No, -3, comma 5 is that open circle point there. The bottom of that vertex there of the absolute value is at 0. That's 0, 2. And then it's going to connect up with that line right there. And this is something that maybe it would be easier if I had drawn it separately, but that's okay. So in this space right here, when you draw in that absolute value, there would be an open circle with the absolute value graph. That's at 1, comma 3. So you kind of start with 2 open circles. But then what happens is when you go to graph the line, okay, and really just start plugging values in. If I put 1 into the line, 1 times 4 minus 1 is 3. So the line ends up at the same point, 1, comma 3. And because of this less than sign, it's going to fill in that hole. So the red absolute value puts a hole there at 1. And the purple line, which is all of this, fills in the hole at that spot. It does look like there's a typo in my graph here, so it's a good thing we're going over this. So my graph should have an open circle right here because of the less than sign at 4, and then a closed circle on the parabola part that doesn't even look like a parabola because of where it's located. So the main thing you'd want to do for this parabola part is figure out what value you get when you start at 4. So this point right here is at 4, and then put 4 in for x squared minus 5. So 16 minus 5 is 11. So that point right there is 4, comma 11. And then the parabola is so steep by this point in time that it just kind of looks like a line. It is curving, but it does definitely look like a line at that spot. That parabola would be like all the way down here. The vertex is all the way down here at this spot. You don't use it because you're starting at greater than 4. Once you graph it, then you can see that the y values, the lowest y value starts at 2. And then because this parabola goes on the greater than or equal to 4 part goes on forever, it goes up forever. So your range is 2 to infinity. Okay, like I said, if you need to pause to copy stuff, just pause and then, or, come back to it as well if you need to. Okay, so now this is the same function, only now we're talking about it with just evaluating. And usually evaluating, I think you guys were doing a little bit better with the evaluating, so hopefully this will go pretty fast. So when we first go to figure out f of -5, you're going to see that -5 doesn't even fit into any of the windows. So this is not possible over here. F of -2 falls in this window. So you're going to substitute the -2 into that part. So that gives you 4. F of 1, though, and this is where sometimes we get confused, so pay attention to this part. Oops. What red there? 1 has to be here because that's where it's equal to 1. So you're using that equal to sign to tell you to use the middle part. So 4 times 1 minus 1 is 3. F of 3 actually falls into that same space there. So it's 4 times 3 minus 1. 12 minus 1 is 11. And then f of 6 then is when x is greater than or equal to 4. So you're doing 6 squared minus 5. 36 minus 5 is 31. It's all about paying attention to the domain window for each portion of the function. Here's all the answers, but I just gave them to you. So, okay, example 3. This is not graphing, it's just understanding this piecewise. This is a more common pretty common type of a situation here. So it says your dog groomer charges according to the following function, with f of x representing the total price. Always important to pay attention to those words. F of x is the total price, and x represents the weight of the dog in pounds. Okay, so all of this is weight. So basically, when you read this, if your dog weighs between 0 and 15 pounds, then you're going to get charged $35 for grooming. If your dog weighs between 15 and 40 pounds, then you're going to get charged $40 for grooming. And if your dog is bigger than 40 pounds, then they're going to use this formula, which basically says they're going to charge you the $40 from above plus $2 additional for every pound more than 40. So that's what this is saying. So like if your dog is 42 pounds, then they're going to charge you $2 for each of those 2 additional pounds. So it would be an extra $4. Okay, so let's see if we can answer these questions. So if your dog weighs 15 pounds, how much will you pay? Well, I think I kind of just described it. So here's the 15. It's equal to here. This is $35. If your dog weighs 35 pounds, that's in this window, and that is $40. Keep in mind, if your dog weighed 39.9 pounds, they'd still be charged $40. If your dog weighs 56 pounds, how much will you pay? Okay, so let's do red here. So this is what I was describing a few minutes ago. So they're going to make you pay that $40. Then you're going to pay $2 additional for each pound over 40. So you're going to take 40 away from the 56. That's 16 pounds, or 16 additional pounds that you're going to multiply by $2. Okay, so 16 times 2 is 32. So you're going to do 40 plus 32, which is $72. So once your dog gets over 40 pounds, you get charged per pound, is what this is showing you. And then the domain of this function, okay, is technically, it starts at 0, but you don't include the 0, because obviously if you don't have dog, you have 0 pounds, then you're not going to go to the groomer, right? And then it's technically goes on to infinity, because there's no stopping of the domain here, but obviously realistically you're not going to have a dog that's infinitely large, but that's just how the domain of this function works. Okay, well, there's our answers again. All right, example 4 now is we're going to write this formula together, okay? So you go to Jewel to buy some candy. You decide to buy Snickers because they have special deal on Snickers. Fine, that's my favorite candy bar. A pound bag of Snickers costs $3.45, but if you buy 4 or more pounds, then the cost is only $3 per bag. So you can save a little bit of money if you're planning on buying more than 4 pounds. Write a piecewise function to represent the situation, and then use it to determine the cost of both 3 bags and 5 bags. Okay, so here's how it's going to go. So you're going to have 2 parts. You're going to have to do one like this, I think, in your closer and definitely in your homework. So you've got the part that is $3.45 per bag, okay? Or per pound, excuse me, okay? So, and that's a pound bag. So it's $3.45. But this is only if you buy less than between 0 and 4 pounds, right? So we'll say, okay, so between 0 and 4 pounds. And I was reading this right now to make sure I was reading this correctly. If you buy 4 or more, so that means I don't want it to be less than or equal to, I want it to be less than, because the 4 is going to count in the discount. Buy 4 or more pounds, okay? All right, so now here, the next part is where it's a little bit confusing sometimes. So it's going to be $3 for every pound, for every bag. I don't know why I'm using a parenthesis there. So 3x, but you have to buy 4 or more, okay? So now once you've figured this part out, then you can use it to figure out the cost for each situation, okay? So here's the answer again. I already had it worked out over here, so I wanted to show you the answers. So if it is less than 4 pounds, so 3 pounds, it's going to be $10.35. And if you buy 4 or more pounds, so our 5-pound example, then that's going to cost us $15. Okay? All right. So now I'm done with the video portion of this. So you're going to go ahead and go back to Google Classroom. There's a closer linked on there, and you're going to use do the closer before you leave so that I know that you did some work on this and that it makes sense, how much it makes sense to you. So I know when I return what you did and did not understand. All right. Have a great day.